Welcome back to Applied Algebra. We are finishing up Chapter 6 by substituting data into formulas. There are two ways that you can do this, and I will show both of them to you, and you can decide which one you want to do. So in example 1, as in all these examples, you will be given a formula and asked to use it to solve for something. So in example 1, we have a velocity formula. The velocity in the final equals the initial velocity plus the acceleration times time. And they want you to find the time. So one way that you can do this is to go ahead and plug the numbers in first. So VF is 193.1, VI is 14.9, A is 18, and you're solving for T. So it looks a lot like all the equations you've been solving up to this point. So now you can just use the same rules. So I would minus the 14.9. So 193.1 minus 14.9 178.2 go ahead and divide by your 18, and we end up with T equals 9.9. So that's one method, is just plug in the numbers and find out what your answer is. The second method is to solve for the letter first and then plug in the numbers in. So if we try that method on this one, so with this formula we're supposed to solve for T1. So what we do first is isolate T1 in a similar manner to what we did on number 1. So the first thing we would do is move the W and the C, so we're going to divide by WC. That gives us Q over WC equals T1 minus T2. Then if I want T1 by myself, I still need to move the T2, so I'm going to add the T2. So I end up with T1 equals Q divided by W times C plus T sub 2. Now that I have T sub 1 by itself, I can plug in the numbers. So T sub 1 equals Q, which is 18.9, divided by W, which is 3, times C, which is 0.18. Once I get that answer, I will add my T2, which is 59. So now I just have to plug all that in. So 18.9 divided by 3 times 0.18, and then add 59, and I get T sub 1 is 94. And I don't have units, but that's okay. So the book tells you to do the second method, but you don't have to follow those directions. I'm not requiring that. You can use method 1 for question 1 where you plug in and then solve, or you can use the method on question 2. To do the next problems, I'm going to go ahead and use method 1. I find more students tend to use that method. On number 3, given E equals mv squared over 2, find m. So I'm going to go ahead and plug in first. I have 484,000 as my E. Equals m, which is what I'm solving for, times v, which is 22, and don't forget to square it, divided by 2. I'm actually going to go ahead and just simplify this right hand side here. So I'm going to go 22 squared and divide that by 2. So I have 484,000 equals 242m. So all I did was combine this and do the math. So to get m by itself, I'm going to divide by 242. So 484,000 divided by 242. So I end up with m equals 2000. So on number 4, if I plug negative 20 in for C and solve for F, negative 20 equals 5/9 times F minus 32. Many of you probably will look at this and think that you should distribute first, and you can, there's nothing wrong with that. I actually would like to move the 5/9 first, so I can divide by a fraction. I do have a calculator that does fractions. If you don't, maybe you have one on your phone or on an app or on the computer. So negative 20 divided by 5/9 gives me negative 36, and that equals F minus 32. Now I'm going to add the 32, and it ends up being a little chilly outside. It's negative 4 degrees. So our last one here is a situation. A drill draws a current I of 4.5 amps. The resistance R is 16 ohms. Find its power in watts. And here's our formula. I'm looking for P. That's handy that they're having me solve for what's already isolated. I is 4.5. I'm going to not forget to square that. And then I'm going to multiply it by R, which is 16. So I can just go ahead and plug in. 4.5 squared is 20.25. 20.25 times 16 gives me a P of 324. Now I know what this is labeled in, so I do want it answered that way. So if I know what it should be labeled, then I do want it labeled. If you have any questions, please let me know. Otherwise, go ahead and finish this assignment up and study for your test.